Welcome back to MPB's Boot Camp for Algebra 1. I'm so glad you joined us. Let's go ahead and look at our Lesson 6, which is quadratics. These are the standards that go along with our quadratics. We want to remember how we factor, how we take the square root, complete the square, and use the quadratic formula. Remember our song. You never want to forget that quadratic song. The power of reading carefully. We know that we have to read, we have to annotate these questions to know what we've got to use and how we're answering our question and what we're answering our question for. We are looking at Mississippi Department of Education test sample questions. So here we go. Numerical expressions. Which numerical expression provides the solution to the equation? Now, I'm going to tell you how to work this problem and not worry about, do I have to complete the square? Do I have to use the quadratic formula? Am I having to look for the discriminant? Okay, there is a much easier way to do this. What I would do is plug my 7x squared plus 4x minus 8 equals 14 into my Desmos. Find what my solutions are. Where does it cross the x-axis? Then what I'm going to do is I'm going to plug in -7 plus the square root of 240 divided by 2 and see if that's my positive answer. Then I'm going to put -7 minus the square root of 240 divided by 2 and see if that's my negative answer. So this is another way that we can answer these quadratics. So once you have this, your equation in Desmos, you plug all of these in, adding and subtracting for each one to see what equals where it crosses the x-axis. When I do that, what did you get? Well, when I plug this into my Desmos, what I'm going to find is this is my answer. So let's see. We have this is an irrational number, so I am going to get decimals. So you want to make sure that you understand that -4 plus the square root of 632 divided by 14 is going to be your positive answer. -4 minus the square root of 632 divided by 14 is going to be your negative answer. You want to make sure that you're understanding how to read your answers and go about finding which answer choice is the correct one. Good job. Steve is using completing the square. Steve is using completing the square method to solve a quadratic equation. His first two steps are shown. Fill the blanks to complete the square in step 3. So remember, we move our old C out to make room for our new C. To find our new C, we take our B divided by 2 and square it. So I would have 16 divided by 2, which is 8. 8 squared. I am adding 64 to both sides. Good job. Don't forget the quadratic formula song. Opposite of B plus or minus. Let's take the square root. B squared minus 4AC all over 2A. Here we go. Which equation could be used to find the zeros of the function? So what we're going to do is, again, you're plugging this into Desmos, and you are going to see where it crosses your x-axis, and then you can take each one of these equal to 0 and see which one of them have the same exact answers that is on your graph. So when I do that, I have x equals -3 here, x equals +4 here, x equals -3 here, x equals +5 here, x equals -3/2, x equals +5/3, x equals -4/3, and x equals 3/2. So my answer when I'm looking at my graph is going to be C. Good job. Which statements are true for the function represented by the graph? Laura is working with her coach to improve her tennis skills. A graph of Laura's latest serve is shown. Big word, shown. Select 3 answer choices. The answer choices are going to tell us what is true that's represented by the graph. So the first one says the function increases for all numbers. Well, let's see. I'm increasing, but then I start decreasing. So this is not the answer. Then it says the function decreases for all real numbers. Well, we've already shown on our graph that that's not true as well. It says that the function is increasing on the interval 0, which is less than t, which is the interval we're talking about, which is less than 0.38. So 0 to about right here, which we could say is 0.38. So this is true. This is exactly true. So then it says the function is increasing from 0 all the way to 8.3. Well, that's not true because the graph doesn't show, so that's not the answer. The function is increasing on the interval 6 all the way to 8.3. Well, that's not true because it doesn't show 6 to 8.3. So I had the function is decreasing on the interval of what? Here, which is 0.39, to here, which is about 0.76, which that's true. Then it says the function is decreasing on the interval of 0.76 all the way to here, which is about 1.1. So this one is true. So sometimes you're going to have questions that have more than 1 and 2 answers. So you always want to make sure that you're going through all of your answer choices, making sure that it does represent what you're seeing in your graph. Good job. Let's look at the next one. Kim wants to earn at least $65. Okay, so Kim wants to earn $65, at least $65 for her 2 jobs next week. At most, she can work 15 hours. Her first job pays $5 per hour, and her second job pays $7 per hour. Let X represent the number of hours worked at the first job. Y represent the number of hours worked at her second job. Which system of linear inequalities models her situation? So let's go back and annotate. At least, meaning she can make $65, but she really needs to make more than $65. All right, so to do that, she's going to take her first job, which pays $5 and is represented by X, so 5X, and I'm going to add her second job. And her second job is $7 and represented by Y. All right. So then if that's the money, remember we always have one for money and one for number. So it says that she can work at most, meaning she can work 15 or less. And we have her number of hours at the first job and number of hours at the second job. Do I have a system that means the same thing that we have written? Yes, we do. Choice B. Good job. Here's Sam. Sam ran a distance represented by the expression 2x plus 12. Lee ran a distance represented by the expression 6x plus 36, which describes how the distance that Lee ran compares to the distance that Sam ran. All right, so let's look. It says that Sam has 2x plus 12. This is Sam. And Lee ran the distance of 6x plus 36. How do they compare? So let's see. When we compare them, what do I notice from Sam to Lee? Well, let's see. His constant goes from 12 for Sam to 36 for Lee, and his term 2x goes to 6x. So what could I do to Sam's distance to get Lee's distance? Yes. I could take Sam's distance and multiply it by 3, and I would get Lee's distance. So then when I come over here and look at my answer choices, the distance that Lee ran is 3 times the distance that Sam ran. So we want to make sure that we are looking how we compare these expressions. I am so glad that you came to review with me here at MPB's Boot Camp. I am Ms. Killen, and as always, have a great day.